And it's live. Okay. So another day, another weather operation is gonna. Last time I finished the first 5 important parts from the original work. I was editing SLP, which is the sea level pressure. And at this point, I came across missing data. And I have a very primitive fix for that, except if 2 rows are missing data, just going to the previous index will also give missing result. So we need to write some kind of recursive, and this is actually a good candidate, let's say, for utils to have that kind of function. We have some functions we already use, normalize, denormalize. This has to be brought back to this area. This is actually not going to be used. This is going to be done in Godot. Let's just get rid of it. But we need some kind of function here that is going to give a healthy value in a certain category by going back in the index or in the following index values back. So I think there's already something very similar logic-wise. This average function. This is accepting the whole data, and which is records here in this case. Field is it's going to be SLP, and this index will be important too. I'll explain why. And I don't think we'll have a min-max. It's going to be very similar to this. And the reason why I'm talking about this index, field index, let's look at our data again. For example, this one. How can I bring this view layout? Is there a temporary way to make this occupy the whole full screen, and then I go back to this split view? Yes, there is not. Maybe I'll show it in. Either way, let's find some value here. So if you have been following previous streams, you will know or remember that for each column under weather measurements, in this case this is a measurement about pressure, you don't have just one value, you have comma separated values in the value section. The whole thing is comma separated, but also each measurement's details are comma separated too. For example, this is just reading this. This is weather direction. This is the angle. This is the quality of that measurement. Normal wind scale. This is the wind speed, 4.6 meters, and they are pretty accurate in that measurement. So we can't just give SLP or wind because it's going to include all this. So we gotta give the index. So it's going to parse this, split by comma. And when we say we just want the 0th index or 3rd index, we are actually interested in that numerical value. It also means we have to do parse int or parse float. Here we go. Let's hide this. I will, I think, get back to this area. This doesn't need to be. Let's give ourselves a bit more space. So this function will be something like find previous healthy value for what? Data, we are going to have field. Let's go field index again. We don't have min-max for this. So we can do for each here. Do data. And because CSV is basically a bunch of rows, let's consider parts of data as row. Each row. Well, here we are not actually parsing the. We have already converted it to JSON, but we consider each object in JSON as row so that we could make some parallels between that JSON structure and CSV file. So, because you wouldn't be able to do something like this, you can't write this in CSV. But because it's converted to JSON, there's going to be a field. So again, very close to this. In fact, let's actually take it. There's going to be value. Sometimes that value has to be integer or float. So let's assume it's float, but there's a different problem right now. Because sometimes these values are on a scale of 10. So the usable value, you have to divide it by 10. Does it even matter? Are we interested in the raw value or the factored value? Here's the pressure. The reason why we have this trouble is let's look at the yeah, we do convert the temperature text to float temperature, factor in the scale. This is it. This may still be above the or outside the min and max. So here is yeah, we'll have to bring our SLP record fixing back to this due part 2, and I think if we are doing that, we gotta do EMP as well. I think that's when I first realized that we have a problem with the SLP. Well, in that record. We'll get back to do EMP and we'll also double check visibility cloud. Should be a 6th one. Viz sig EMP due SLP. Hit the JSON here. Yeah, I'm probably missing either wind or viz one. Wind, sig, viz, TMP, due, SLP. So 6 core ones, and then okay, we'll apply this remedy to other mandatory fields. For now, question remains. These are essentially similar. So constants right there. SLP. Okay. Let's run this in power. Go to F, change directory. I'm going to run the expander, which is, so this is giving us some results. At this point, maybe we are not going to have this primitive fix, because that's also giving us 999 rows. So let's go back to the raw error message. Oh, here we go again. Okay, so whenever I have a very big file open, somehow VS Code freaks out and I have to start it. Yeah. Now this line is okay. Denormalize. Yeah, I commented out the function, but I'm still returning index. Yeah, this fix that we are trying to work out in SLP, we have to apply it to do, as I was saying. VS Code freaked out and closed again. Okay. Try again. Anyway, the result is still here. So SLP is saying that line or row 67 has out of bounds pressure. What does this mean? Let's go to Excel and this is the file. You gotta run the rows. Don't want to save it and it. So under SLP, line 67, SLP. So this is out of bounds because the minimum and maximum for SLP has to be this. Yeah, I think I'm already answering my question about the factoring in here. Normally this is 8,600 and this is 10,900, but that's according to the documentation. I guess it's page 9. Soon after this, one more page. Yeah, 8,600 and then 10,900. But because I know this is going to be scaled down by 10, I am choosing to write 1090 as the maximum decimal value or the float value, whatever. So when we are writing this, it's okay to leave it as it is without factoring more. You don't need to factor in the scale again. We'll get to this part now. Now that we know we have out of bounds, this is a semi-manual or semi-automatic process that when I run this code, I'm kind of expecting to see problems. This is running over 2010 data so that I can apply some custom fixes for each year's values. But there are generic fixes such as this one, finding the previous healthy values. So let's so as a dumb fix, one might think that, well, all the way 9 means it's missing. So for some reason they couldn't fix it. So maybe we should use the previous hours value. To do index -1, get the value. Except sometimes you have two rows saying 999. So if this is 999, fix this. You're basically filling in another junk data, junk value. So here we gotta do recursiveness. In fact, if you look here, output, we are going to see two rows in a row. We have missing value. Here is skipping just one, also very close problematic. In fact, these three are just skipping one. I said this is going to be similar to average, but let me see. We have the data. We need the SLP. Here, output this. Find previous healthy value in all the records for which field SLP. And the field index is 0. I know that because when we split this string by comma, it's the 0 index. So what else do we need? I think that might be it. Essentially, this value should and I'll hide this. Everything will be fine. We do know the index, sorry, not you know which exact row. This index is actually a row. I should have typed that. This is the record itself. This is the index that is the for each index. This is like JavaScript for each. Forgot the name. Iterable. This is the item we are trading on. This is its index number in all iterables, and this is all the records. So this record exists in all the records at this index. So that's what it means. But in this context, index kind of means it's a minor detail. You could just swap that. Either way, find previous healthy value doesn't exactly know which row has the problem. So instead of working on all the data, instead of passing all the records, perhaps we should pass index. However, this guy doesn't have access. So in all the records, still need to pass index, which which is this current problematic index. So that's essentially doing this. In all this, it's line row this. And we say it's SLP, which is this. Then we say it's the 0th index, so split this. So maybe we don't need this. What we need here is this. In all the data, and data in this context is JSON. Happens to be the index number. Is this. And then we do have field. Split that. Find the index. This is giving the exact same value. I want to first confirm that there are a lot of moving parts here. Let's bring back this error statement. So essentially it's saying, hey, this row has out of bounds pressure. Let's divide this text a bit. Okay. This row has out of bounds pressure. Because its value find previous healthy value is its index field is SLP established and the index. Now we know that this row has out of bounds pressure, but we will also get the value that is making it out of bounds. So we are not going to get the fixed value yet, but we are kind of outputting the problem. Yes. Value is undefined because when you don't return stuff, here we have all the problem cases as we can see. Okay, line 67 is out of bounds pressure because it's value. So we now expect to see these values to be fixed. Now, in this first case, 67, we could just pretend that, okay, row 66 maybe has good value, right? However, we have already established the fact that not really depend on that because 7601 and 02, we can't just go back one. Here. So this one has to go here. This one has to go here and here. Now, here's what might also happen, though. When we branch out to this area, we are still in the main big loop. This is essentially running inside a global loop. The only, like, what I'm trying to say is when we come here and we figure out there's a problem, you replace this value with this value, and then after we think we are actually fixing, we have fixed this value. When we come here, if this is problematic, we are reading from here, hoping that this value has already been fixed thanks to this. But right now, I'm not making those fixes permanent. That is because everything that I say it's okay, just keep processing and keep working out the main loop. If everything is okay, instead of writing things permanently, at that point, going to create a noise map. So this guy really will think that previous value is still wrong thinking. Here's our chance to see whether my interpretation of this whole thing is correct or not. If we do something like this, instead of reading the existing value, say, well, read the previous row's value. This is no different than this line, except it's taken out into details so that all the other methods. Now, when we look at this, when we run this now, I'm expecting to see 76, 01, and 02 to show proper values. Yeah, I think it's actually fixing it in or not. I was looking at this one. Should have looked at this one. Yeah, this is exactly what's happening. So the first one gets the fixed value from previous, but because I'm not actually writing that in this field, this guy still reads the wrong previous. So because while all this is working on the JSON structure, I'm not updating parts of it. I'm only necessary chunks, and at this point we'll do this map image creation. So recursive function. Let's remember how recursiveness works. So there's usually an if-else case. Okay. So normally recursiveness works like this. If check something, if it's false, then you do this, find this, has different condition in this case. We just looked at the previous line, and if this is a problem, which is good in this case, then run this method again, assuming that we are interested in the previous row. So then the second time it comes here, it's actually kind of looking to indices back. That's really what it is. This will work, except you gotta make sure that your false condition is fine. If this is returning true, which means if the condition is true, then you're actually returning this anyway. So in other words, if everything works fine, This guy should be replaced with this one. This guy should also be replaced with this. If you had many more 9s here, they should all be replaced with this one. The previously known good value. That's really what it is. Find previous healthy value. Or find last known healthy value. So, and how do we know if that value is healthy or not? Our condition is based on whether that value is in the boundaries, it's in min-max. So this false condition is contingent on this. Now, this is a whole other this is already okay in the yeah, when you return it here, this is gonna be a little bit grayed out. This SLP is exactly the field that we are. Hey man, how are you? Easily past the field here. Sorry, this string. This is the problem part though, because this is looking up this. How are we doing? Because this has to work in a generic way, right? It shouldn't know anything about the fields. Hard-coded. So for this to work here at this level, we also gotta pass this into this healthy value. Get away with the field. See, this pressure is kind of the index here, but that is not essentially mapping here. Just woke up, it's 3:15 here. 3:15 in the afternoon or just in the dark, like in the morning? If you feel rested, it doesn't matter what hour it is, but to me it sounds like you just woke up in the middle of the night and you might be sleepy or tired. 10 a.m. Okay. Well, you'll have an early start today then. Might be good. May get a lot done. To fix this data. So massive data wrangling, data manipulation, interpretation, big CSV JSON things. That's really what's happening right now. If we pass pressure here, this value is the current value that we are reading. This is this part is done. This field is sorry, field index is essentially the index, but it's not the name. So let's also pass the field name. Will mean, yes, we do know 0th index is pressure, but here is index pressure. So let let the previous value be this. If the previous value is still not in min-max, pressure is going to be the field is still field. So this is going to be looked up in this in min-max, which is going to check whether the previous value is still in the boundaries or not. And this is your false case or not. So because the way this function works, if this returns true, you have a problem. So yes, it is in fact not in the min-max, which makes this if condition true. If that is the case, then you go one level deeper. Let's actually look here. We also need to provide field name here. The only difference is the first time this is running, it's accepting the problematic row, looks at the previous row, there is still a problem, and by passing the previous row, next time it runs, it's going to look at the row before the previous one, in essence from the original entry point. The second time this function is running, it's actually looking 2 indices back. So we need to bail out though somewhere here. So else, because you always need an else case here, otherwise your recursive thing will blow up and then you'll be unhappy. Can I increase the font size a bit? I sure can. Is it good? One more? Do one more? Yeah, I'm kind of used to seeing very small font size. Yeah, let's do one more. So if it's in the boundaries, then it means the previous value is actually good. Just return that. Good. Cool. So this should be just fine. Let's. I think I'm going to rearrange some stuff because now. See, this could easily come here. This is my generic thing, so let's put the find. This is sort of part of this process. It's doing all the 6 here. Why do I have utils here double? Okay. But I'm going to open one of these soon, TMP, to bring back this introduce this thing into there. Okay. Now when we run this, these 2 lines should say, well, it's out of bounds, but we'll use value this, and then this one will also say, yes, I'm going to use that value to run it. It's 10 to 3, 4. SLP of undefined 68 of undefined. Records index field is SLP. Field index field name pressure. Probably messed up the order of things here, right? But I was careful. Field index field name. Data row -1. Whereas I remember data is an array, So here's the index number. What is there? SLP is undefined. Really? How could SLP is undefined? Let's look at the record. If I look at the record in VS Code, it's probably going to crash again because it's silly like that. I open this maybe. Yeah, let's open this here. Okay. So this is the JSON array. By passing the row, I'm looking at the indices. For each one of these, there will be SLP. So how could you not find SLP? There's no typo, it's SLP. Data. So here's what we can do. Prematurely bailout. We do something like return data row -1. And let's also not worry about field. Let's just output that row. This one. And of course it's going to say that's an object. Gotta parse that. Hopefully this guy will. What's happening? Let's do object entries. Wow. Okay. So it really doesn't have SLP. This is like the header. Let's look at the keys. Is this? I'm interested in the values. Okay, so that's good news. So oh, okay, they are pairs. Here's date and then its value. Somewhere here there's SLP and its value, which is this. So it's the object. You know, shamelessly give me the field itself. It's SLP for sure. So why is this not working? It does work, and then you split it. Then you take the field index. So now you seem to work. What? Oh, okay. I answered my own question by thinking, okay, the when I get these values, they're even if I think I'm getting the right value, this is not factored in by that scale. This is not taken into account. So of course, even the valid integer. In this case, yes, it's not 999. It's some valid integer. That's good. But the fact that I'm accepting it as 10,234 is still beyond the boundaries. Which is making this a true case, so the recursiveness is never stopping. And then at some point, you go all the way to the first row, and then there's nothing to find, and then everything. Not good. So, gotta do something about it. Am I even passing the... I don't think I should be applying the factor here. Because when I do this is presumptuous of me, because I'm assuming everything is good. But if for some reason it's not good to find it, I have to be dividing loop values here by this factor too, right? So forget this. But if you do this, you gotta go to this, and this has to be different. I think for do the 2, I think that was also 10 because I typed 10, right? Yeah. It's a bit of a different case, so no, actually I have to multiply. This way too. Visibility, that is not factored in. That was just really straightforward. This is okay, done. Okay. This is 1, so that's also 22. Wind is, I think wind is by 10 because, yeah, meters per second. Only the speed though. This has 2 chunks, everything else has so far 1. So we need to make sure we have to come here and apply stuff anyway. Visibility was fine, we haven't hit that. Temperature, we have to miss it, so let's do this. So I have to fix this too. Wind is, I said I fixed it. This is still gonna work out. Sig has not been touched. Visibility not been touched. All the rest is fine. Sleepy or SLP. Sea level pressure. That's fine. Save everything. Go to utils. This logic works just fine. But it was a bit prematurely calculating the correct value. So let's run it again. So again, we are interested in these two. That something like this should show 10, 2, 3, 4 for both. In fact, we do have it. Everything is working just fine. So we have a recursive function. Is working okay. Now would be a good time to grab some tea and continue. Okay, let's tidy up something. Um, Essentially, you could just say, well, this guy has out of bounds pressure. This is where you could do error logging or whatever. This is what's going to be the value of pressure now. So you technically do something like, forget about this. Just give the error, but pass the good value to the pressure. In this case, I'm actually not going to bother with this. Tell you why. This is something that is redundant. Reason that is, let's this area. I do have a template JS file, which is very which is the template for structures like this thing that you see here. So I create a copy of this and then put the required weather property. So we have two basic checks when the quality codes are not good. So then this is reporting there's some poor quality stuff. Maybe we gotta do something about it. Or sometimes the measurement is okay, but it's out of bounds. This is quickly replacing this. Nevertheless, I have both. So you might also have the same problem. Now that we actually got rid of the error here, or the console log, that means if we run this again, we won't see any error reporting for the SLP, but we still have some problem with you. This is when I tried to do the previous row thing. Led me to seeing that previous values might be a problem. So we got to apply the same fix here. Something like this, if it's not in min-max. Okay. Instead of outputting this message, we are essentially doing something. The new temperature is could actually do something according to all this here, but new value. This will pass the temperature here. Fixed value. In all the records, this SLP is going to be replaced with due. Here constants under due, we do have temperature, which is usually exactly like this anyway. Because this is sort of replicating this part. Okay. That's really it. So when I run this, it's going to say 67 has blah blah wrong records, but it's going to be fixed to this. We should exactly see this one, except here we'll see something meaningful. This whole thing is to prevent this problem. Let's see. Explodes. Record index records. Do I even have this? Yeah, see, I copied and pasted. It did not import the function. So this is still the same, which is good. But that was the primitive previous row value. This one is fixed. 8156. 156. So 8156 has out of bounds temperature. This one. This. No, actually, these two were problematic, right? Same. Okay, yeah, it's same area. Those two things. Yeah, they are both going to say 0.60. Good. When everything is in the boundary, there is still a bit of a problem here. I'm not factoring in the scale, because for normalizing, I should factor it. However, from this perspective, you know, this is kind of working out. Because if I'm putting 10,000 something value, which is less than max, let's imagine, just 10,000, okay? When I normalize it, it's still going to be between 0 and 1. From that perspective, nothing is changing. However, the value that I read back after normalization will be read as 10,000. So when it goes into Godot, I have to factor in there. Same thing applies to temperature. This is essentially 61.8 Celsius. But if I keep all this for the sake of simple calculations, the normalization value will still be fine. But careful. So this is due. Let's do the temperature fixing as well. Similar idea. Pull this here. So this row has out of bounds temperature. Luckily for us, EMP here is column G. Doesn't have any out of bounds temperature. This is only for 2010. If it did, then we would have to do some. So we don't really need this anymore. We just fixed it. Essentially, we are using something like this. And I haven't even begun not normal, the noise map construction. It's going to happen somewhere here. I will most likely ignore quality because I'm also checking. Okay. So temperature in 2010 case, it's okay. Visibility is okay too. There is no problem case. In fact, at this point, I thought that variability is not really an important thing in the game. That should be fine. Again, none of this is output, so if we run this, it's going to say all has been processed with or without it. We still have to do this. That's fine. All fine. So we have the core 6 bits of information. for 2010 sanitized. So we no longer have PP999. We haven't begun this part, which maybe not important right now. So what should I do next? Are we are kind of at that point to store weather data. Let's look at our files. From here, we are creating an Excel file. Through some magic, a macro, we create this. Then we have a Node.js process that takes this file, spits out this file. And the same process is also working with this file after the conversion that is responsible for cleaning up and error reporting. So at this point, we could be creating our noise map. You're wondering what the hell is a noise? Something like this. So we'll be creating our own map with grayscale values. That's why I've been normalizing. So 1 will mean white and 0 will be dark. Any value in between will be 50 shades of gray. More specifically, 255 shades. Yeah. I'm thinking whether I should continue with the chunks here. By my calculation, there are possible hundreds, over 100 values or chunks. Measurements. Measurements is still not the right word. Over 100 identifiers. Some of those identifiers come with multiple values, multiple measurements. Not all of them are important. Discovering it is necessary, but maybe not relevant right now. What I'm debating. Because for the player, these will be the most interesting or important parts. So we do have TMP. We don't have humidity or humidex. We could calculate humidex through wind speed and humidity or temperature, separate thing. I believe there is something about humidity. We do have wind direction and speed. We are covered. We do have pressure. So out of 6 properties we have, this is the extra one that we don't really make use of. Also, we don't really make use of this either. But these two will be sort of foggy condition. How cloudy there's some sun coverage and whatever in some. Essentially, wind speed and direction, temperature, dew point, and pressure. So we do have that. So we could start prototyping this with real data. And I will just investigate how we can create a noise map with Node.js. I type Node.js, what I actually mean script noise map, not JavaScript. Use Perlin noise to make a map. How to create a Perlin noise with JavaScript, what we are after. Wow, we are not creating Perlin noise because the most randomization. We are trying to create an image file. So image file, create image file. I think NDN will be my best friend or worst enemy. How to make a simple image? I'll upload using this. Something like this. Let's start. New image, source picture. Okay. Let me see if this is already exposed here. For this, I'm gonna need a new process, which is not a cleaner, but similar to utils, except its own thing. So we'll imager, noisemaker, other written name. Okay, noisemaker will do nothing but also log. I will make a lot of noise. Okay. At this point, could afford to have another PowerShell. We'll do F. We'll do change directory. Do click there. We do have noisemaker. We'll just do node noisemaker. It's going to make a lot of noise. Now, let's have something like let image is image new. Of course, it doesn't work like that because it's not GD script, right? The new image. Now you say image source is something, but here I'm trying to create the bits of the image. I think it thinks of this image as HTML image, alt and source. There's something like from data. Yeah, it thinks of this as HTML node. Gotta be able to write something into this. Natural width. To data URL. Let's look at image here. The data. Underlying pixel data of an area of a canvas. is created using the image data constructor created methods. So I did all this work in JavaScript. I always considered the possibility that I might have to transfer this to script. That day might be approaching. Create image data. See if we can select data. New image data. SWSH. Settings. Image data settings. Data. Clamped array. We could be giving unsigned integer clamped array. The fact that that's 8 makes me think it's already doing 255. Because 2 to the power 8 is 256, which is after a. Let's just do something like this. Did you say data? Let's call you image data. Call you data. You int 8 clamped array. Field types. This is coming from somewhere within Node, I think. Object unknown. This is going to be interesting. So you don't do data push like it's a normal array. What if you do some kind of conversion? Keep importing that. Do something like, I don't know, 127, 64, 80, 255, 0, 50. In fact, keep filling some other garbage values. Here's image data. Here's sh. Kind of width. Say, because I have that array of 9 image. Then width and height 3 by 3. Image data. So okay, let's keep reading. Create image data, get image data. There is no such thing. I don't think it works like that. Because I'm not reading this carefully. Except also this is working on canvas. This is experimental, I believe. Ocean bottle. Which data read on. My assumption was right about this. Could actually, in fact, do this. Very like, okay. In fact, why is this even in uint from this array? This is returning integer. This is the one. Gonna sound dumb, but image data is not defined. Data array should be defined. An unsigned long representing an array containing the underlying pixel representation. If no such array is given, which is an image with a transparent black rectangle of the space, just do image data without worrying about this. I have a feeling this is gonna error out too. Image data is not defined. Do a console clear. Do you really need a require? Okay. Perfectly fine with this. Except it's actually a problem here. Let me dump this here. Okay. Image data is not defined. Let's look this up. I don't think this exists in Node context. Yeah, you're mixing up Node and JavaScript. Just as there is no window object in Node, certain browser specific things such as image data doesn't really. Well, you could create a class, but it's not going to work out. And this is when I was pissed off last week. You'll know why. There's no documentation. As far as I know, there's no way to search this documentation, which makes it useless. So you gotta do something like this. Image site this. The whole other madness there. We do docs. Yeah, that's just. There's no image class. There's no maybe binary class. Nothing of that sort. So. buffer, which is a whole other. Would it be too difficult to include some search bar here? And when it said details, what? Pipes? I see. Create image node.js. Let's go with these basics. This is exactly what I don't want to do. We actually have built-in canvas now in Node. Fire black thing, okay. Sigh. Question. Let's not ask that question. Not helpful. Okay, this is your image. There's no native dependencies. You could easily download this file. So the node stuff. From here I create an image. Get the context, then I try to do this here. I'm basically using canvas features, which is setting pixels. This might help. Good for you, sir. Automatically filled with 100% opaque black. Okay, let's give this guy a shot. We just download this. Don't want to do it like that. So I want to. All I need is this. Get that from here. Source. Index. This probably has other dependencies. So I should be. I'm hoping all the dependencies are handled here. Can we just directly download this section here? But there's still no such thing. We gotta download the whole thing and then extract source. it. So this source will be, what did he call it? Pure image. Okay, that's the pure image folder. Some go on. Okay, pure image. So now in noisemaker, you gotta do something like this. Just to get some inspiration here. Essentially, enable this, but do something like this. Pure image, and that's going to get the index and all the dependencies. Hopefully, you just say you are pure image. Okay, and looking here, enough. So garbage. This is actually going to give same error. So I'll do something like pure image make. You actually don't see that. This is not properly imported. Import. What gives? Okay, let me do this. What is going on here? Oh, import everything as images. So it's not module based then. Yeah, it's just single exports. Okay. I'll do as the Romans. Cancel this. Your image. Of course, it's not going to work. You gotta smarten up a bit, you know. Make width, give it 100 and 100. This is going to be output to some constant or variable. Shamelessly take this to. At this point, outputting this into console is really stupid, but go with stupid. Cannot use import statement outside the module. That's exactly what I was afraid of. When you say import everything as JPEG from JPEG.js. That makes me question. What is JPEG.js? Isn't that a dependency that this library claimed not to? How about PNG.js? Like, where is this coming from? Node modules. So there is actually an internal. But okay, wait a minute. The fact that this is here doesn't mean this is part of Node.js, because this is a because we cannot really search in Node documentation. PNG. View as JSON. You mean the whole documentation? View on single page, but again, this is the whole documentation. Yes, because if we go all the way down, we'll see zlib and such. Okay, let's look up PNG. The only PNG is only a string PNG here as part of the arguments. So image, again, same story. This makes me sad. This makes me sad too. I'm questioning my previous choices. Um, how much of this work in data cleanup can still be continued in Node.js? Now, there's a certain level of comfort in using JavaScript, because then I can do things like filtering, mapping, all that stuff, which doesn't exist in GDScript. Not too difficult though to write few nested for loops. But what if we do this work here, and then where are we? So from here to here, we create macroscopic. From here, maybe we create another JSON file where we say it's sort of like, I don't know, level 1, sort of cleaned up data, whatever. That is actually the baseline for script process. Because if I read JSON data in GDScript, then I can create a noise map. Short break and I'll be back. Okay, let's introduce a JSON file, separate JSON file as another layer. Now, speaking of which, I think I'm going to write down my process because I'm surely going to forget all these steps. Let me see if I can this. If I can use Mila nodes for this. Or if I should use Miro. I think I'll go with Miro. Sign in. I think I logged in with the company account. So yeah. Let's create a new board. This board is going to be kind of like a flow thing, right? After this and this. So go with flowchart. To all team members. What team members do we have right now? We have team members. Do it anyway. Create a shared board. Safely move around to use the right buttons. Now, process starts with this actually. History. The process starts with opening this file, something like this. I open, well, not really. There is actually a separate process, right? Which is downloading all these files for us. That process is, we should be deleting this pure image because it's going to come soon. So pure image by here, go back. There's a process that downloads the data and puts into Noah, which is collect city data. And the usage is here. And I say use that file and then just download all the data. Toronto. This puts it into Noah with the proper. This is actually one for one chunk of the flow, okay? But it's actually a good point. Do something like this. Collect city data. That's how we start. All the rest is kind of done once and it's ready. Okay, come here. This is your part. Collect city data. Can we write some kind of note to this? Add comment. This is good enough for me. Here's a note. Read this. This is how we use it. I'll figure that when the time comes. After this, now that we have this chunk, okay, we need to open one of these CSV files in Excel. import CSV to Excel. Which CSV file are you talking? For example, specific cities, specific year. Okay, put this here. Okay, good. They are tracked together. There is kind of need to duplicate this process here. Run NOAA climate data something cleaner. Climate data simplifier. After you import it, we'll fix this soon, maybe. Together. Something like this spits out TSV file to this folder. And I'm going to have that as a comment. This will spit out something like this. Macroscopic standing for macro applied. Okay, now after this, convert this into this. Now that process happens during expansion. The expansion code is just taking it. Let's actually copy this. Okay, and I usually write usage bit here. I think I did that in find average here, something like this. Okay, so node expander, which is this file. Go and find the relevant macros. It's fine. And all this is doing is it's converting the TSV to JSON and starts working on it. Maybe in the end, even delete this TSV file. Let's see. Maybe I'll do this as a whole batch thing. So this is a two process thing. There's Mr. Grumpy data, which is the converter, is writing this file. And then the other process is reading that file right away, and then keeps working on it. This is where we'll probably spit out the cleaned up version. That's where this thing will come in handy. We don't really need this else cases. It's sort of a straightforward process. However, we could just, for the sake of having a branching out part here, say, well, after you do this, once it goes into the expander, that's really what we need. You copy like this one too, perhaps. This, okay, good. This goes into this. So after you run this in Excel, and I'm going to turn this into green color so it's more like Excel. Have darker green. This looks more like Excel color. Good, you do. We'll keep node. This will spit out something like this. Then run expander on microscopic CSV. Okay. Really what it is. At this point, let's move it out of the way. Expander converts, say converts. Maybe I should write it as a converts CSV to JSON, spits out cleaned up version weather data. That's really what's happening. And we'll work on this very soon. We should give it a proper name. Hopefully not a phrasal word, not cleaned up, but sort of sanitized. This will spit out something like this. Commerce JSON to CSV to JSON spits out a cleaned up like. Take this. Sanitized. Okay. It's all done here at this level. I may need to create some kind of legend here, right? There's something like that. Notes to do that. Do I make it part of here? I could make it part of there's Excel, there's Node, and there's GD. What is happening? Oh. What the? You... I mean, select. I think this thing freaked out. Bye. Yeah, we have multiple things going on. This is Excel, Node, and there's Godot. Okay, Excel is this green. Node can be that, and let's pick you a bluish color. Good enough. Okay, are the 3 layers of operation. I don't care about you. Bye. So when we run the expander on microscopic TSP, we kind of go back and forth here about cleaning data. So I'm not going to, well, there's like a find averager and if necessary. But then eventually you come back. This here sort of comes back. With love. What other mechanism are we using here? Other madness. We sometimes use find averager, or we have this internal mechanism. This, this is not going to work out. We do this. You find previous healthy value. That kind of. We have some optional processes. Can we convert this into another shape? Any shape, okay. Let's say this is sort of this, okay. Sometimes you have find previous healthy value. And doesn't it, well, by healthy value, we actually find it in the previous values, but the goal is to find healthy values. That's done. So let's put you here. You go here. You come back here. Okay, let's fix you too. Nope, that looks awkward. So this process requires some at Node.js level. And after this, we have to feed this into Godot. Let's duplicate this. This is where we'll do run noisemaker Godot plugin. Okay, this is going to be part of the existing plugin system that I have in Godot, which is Urban Farmer Tools. But more specifically, we are running the noisemaker aspect of it. It's going to be this. Right. So far, this is the process. Just in case I forget one. Or this is going to be helpful for the next idiot. Let's run expander on macroscopic TSP. We are doing that. We are just about to output the cleaned up version. Then we can start this. Something crazy will happen here. Also, will involve 1, 2, 3, 4, 6. I'll have to fix some stuff here. Because when we are processing all this, normalization is done just fine. This is all returned to for each to this level. Nothing is done though with this. First of all, let's just write a very dumb file. Probably just do it. fs write file sync. The file path will be based on the input file, which is argv2. Okay. Essentially, we want to replace this macroscopic with sanitized. And this is always coming in macroscopic. So we'll do, we actually have TSV path as argv2, so we do something like this. File we want to write, it will be replaced. It'll just be this, doesn't matter. Sanitized. Okay. That's the file name. Problem though, pic.tsv has to be replaced with sanitize.json. Otherwise, this would be sanitize.tsv. We don't want that. The data, provide data. The data will be something like JSON stringify, just an empty array. And you also want to so all this is going to be business as usual. We are going to have sanitized JSON right here, somewhere here, most likely in between these two files. So here we go. Okay, right there. So this is going to be an empty file. Now that has to be filled with the sanitized data coming from all these 6 chunks. See? And the sanitized version, anyone is curious, is going to take this. This is the macroscopic. This is already. This is not processed at all. This is the directly converted file. So that the TSV has been converted to JSON. This is that file. This has not been sanitized at all. By sanitization, we mean we need to extract 220 here, this one. We need to put it into its own property groups here. It's not going to be just wind. This has to be broken down to wind direction, wind speed. In this case, we are interested only in one value. And later, when we are able to process all the other optional parts, we'll do the same treatment, but eventually this is going to be, after the sanitization, ported into sanitized JSON so that it only contains relevant chunks here. Which makes me think that we actually need to do some kind of need to make certain decisions here. I don't care about this. I care about this. Type is something that might be important. Let's just go with this basic determination is how the ceiling height has been determined. I don't think it's relevant. Visibility is distance is enough. I think these last four will be just one thing. The SLP is just the pressure itself. Now let's save all the 6 done. It's not going to be empty soon, but as soon as I dump a whole bunch of data, most likely VS Code is going to freak out and it's going to restart, so screw you. Closing you. So we don't write this file just yet, so we pretend, let's say sanitize data. This is going to be an array objects, and each object will be a certain hour of the day, 2010. So when we are doing it for each, this is where I have to do this delicately, because I did some I made certain choices here, right? Certain decisions. So climate data is essentially this, the whole thing. But the way this structured is an array of objects. When you say you run for an array of objects, for each object, run this function. What is that function? There's a function reference here. 6 functions, and that is the outer wrapper. So for each one of these function references, go to the climate data. Basically, these two things are processing the whole climate data for each one of these properties. So for each one, 6 times process the whole data. After the data is processed, I have to store it in here, but if I do something as something like this, what is going to happen? Let's first imagine or discuss, because it could be catastrophic. Now this is meaningless at this point, because when this is running, it's running inside this for each. This is not really outputting anything. You can actually see that. Trying to find a better this is an example. I'm going to compare this one to map. So this is if like when this is happening, it's returning void. There's nothing. Let's look at map. This is probably what we'll use. Try to so if this was for each, this is the kind of function that we are running here. This function reference is SLP like this, which is sort of like a shortcut here, weather element. This through this is resolving to this, which is sort of like this. So when it's mapped inside this function, the return value is utilized so that map is taking this value and injecting it into the root. There is no such thing happening in for each. Even if you do this equals for each, having a return statement here will do nothing. Which means we have to map this. Problem though, sorry, not that. And also, you don't really need to do push because this by itself is pushed at each iteration of map. But problem is we have a nested data structure. Let's look at this example. We have 149, simple array, an array of numbers. So when we have a map function running, which is taking the square root of these numbers, and this whole operation is mapping numbers to roots. So roots is an array 1, 2, 3, whereas numbers was originally 1, 4. Fortunately, our elements in the array are objects. So I may have to reverse this, so I have to kind of take it, make this here. Operation there. What am I looking for? Weather elements. Let me wrap my head around this. We are going to map the existing climate data. Is this? We are mapping an array to a new array where this is no longer weather element. This is like a row index each one of these chunks. Since each one of these is kind of like an hour, then what you do here is you process no. You process that row for each weather elements. For each one of these, you are passing row into this. Makes sense, but I'm having a hard time expressing it in words. We want to process row for each one of these so that this is essentially a for loop that is running over this. This is nothing but a function reference, which is so when you say for each this, you are essentially passing a row as record here. All we need is index and records. And luckily, when you do this, this is automatically expanded. Let's show you the case. Sometimes it looks messy like this, but I'm confident this will work. However, this may have to be a map too. Tell you why. Because this isn't going to return anything. It's a complicated process there. So this is going to return you know what, this this has to return an object in this case. I'm now making something. This dig. You know, this doesn't have to be because we'll stringify it in JSON. This has to be, this object itself will be put into another object. That whole object will be mapped into sanitized data. That's really what it is. This is what TMP. Because otherwise we wouldn't be able to separate dew temperature from TMP temperature. Normal air temperature. This is what SLP sea level pressure. So now all the 6 is running in here for each. When we return them, this is a primitive way. This is probably not going to work. I have a feeling I have to do another operation here, because here's also what's happening that I'm not taking into. I'm only mapping the 6 properties, but I'm not utilizing this part. This part is probably garbage, but I most likely need this. Let's just go this. That being said, it would not be difficult to just take out the date because I already have. Let's pull this down. Now we are not writing an empty array, we are writing sanitized on this. See what happens. Object is not a function. You're kidding, right? For each, you're looking for an array, which is weather elements. Oh. But okay, wait. Oh, I remember why I had the chunks here reversed. To be able to do the trick. Doesn't check out anymore. Because now I have to separate it. Okay. Other element. Now I really have to do X. The array itself, which is yeah, okay, I have to be passing the whole climate data to row. Problem though. Okay, let me break this down again. This could be written down. Weather element is a function. You know, I'm doing this the wrong way. This has to be all is records. It index is index, and this is just okay. This is in short. Okay, let's see how this goes. For each one, gotcha. For each weather element, which is only a reference to this, which is a function called to this. For each weather element, you gotta do this. Here's your argument. This is still iffy, but all has been processed. Let's go to, let's keep this, copy. In here, we need to look at the sanitized one. The fact that it's 43 kilobytes is kind of reassuring, but everything is null. Sort of expect. This is why I was saying you don't do this with for each. It's dumb. Because function signatures are similar, this is syntactically correct. However, logically, it will still give a result. Might be just the thing that we need. Problem though, it's going to be an array instead of objects. So it's going to act like the first record will be an array. First record should be an object, but let's say it's an array. The array's 0th index will have a wind property, will also have these properties. They are good. But then instead of sig being right after wind as a sibling inside an object structure, they are kind of like 6 things. That's the problem. So there are 6 individual things. Because that means they are not exactly appending. is most likely the answer. It's object append, object entries. I think somewhere here we do have append, right? Assign. So here's target source A, B, B, C, right? In the source case, B is 4. In the target case, B is 2. The object assign target and source. Target is first. Source is overwriting the properties of target. Hence, this is A1. B is then 2, but then replaced with 4, and C is 5. So yeah, we don't have duplicate cases like this, but it's essentially combining both. We have multiple objects returning. We just have to combine them. Which is something we can do here is kind of in a tricky way. Let's have another variable here. I'm running out of names. Call it chunk. Okay, chunk is an object. You don't return anything yet. In the end, you are going to return chunk. However, chunk will be such that you'll be doing object assign, and this needs to take objects. This is our chunk, and we need to feed in objects. Because we do something like this. It returns another object. So in each turn, this is going to be first one. Meaning, into chunk, you are outputting the result of this. It kind of called is let normalized sanitized everything. Okay, that's essentially what's happening. So into or over an empty chunk of combine the normalized, which becomes chunk. However, this is still the wrong place to write this. I will convert this into for each as it was before. Holy shit. Yes. Don't just do some smartass thing here. So this is returning you one of these objects. That is actually the normalized. Actually, I don't need to do this. That is this. Could just be this. Fuck this. So I'm updating the chunk which is outside for each with each iteration. So you kind of figure out good values to it. Then in the end, chunk is good value. Now, when we run this file is still going to have 8,761 indices. It's actually 8,762 records. It says +1 here. That's because this one has a header. Everything checks out. However, this one is no longer going to have 6 arrays inside each row, except it's going to have one. It's going to have all these distributed as of the. Let's run it and then go home. Let's refresh. Do your thing. And ta-da! We have all of them grouped under objects. If you look at the raw file here, so here's one big object. This is it. So this is row 1, which is a whole big object. That object has SLP property, which only has pressure quality, but we still have to follow a structure like the thing. Temperature is something that is could have dew temperature or just simple air temperature. So you don't want to duplicate those things, otherwise you'll be alright. And in this case, wind has direction and speed quality. So you have this whole object representing 1 hour of the day, and that hour has wind property and that has sub properties, that kind of some crazy stuff. So this is actually good news because we have sanitized and normalized data. Let's get this work again. Let's also double check we have proper number of bits. Back with you. So with this normalized data, we are one step close to creating a simplex noise. This is did I normalize this? I don't think I normalize every single thing. Or this is just a lucky accident here. Visibility. I do normalize it. Okay. Just a very convenient number. Yeah, distance, this is just a happy accident. Okay. So the simplex noise is something like this. We are going to create a noise map with some white and dark colors. This is always more pleasant to look at. For example, if this pixel is representing the wind speed, the fact that this is high, I mean, let's say this is the medium value, right? If it's actually lower, it means it's not a windy day. If it's way higher here, it's a really windy day. So the value, the brightness of that pixel, this is just a 3D representation of something. There's going to be a certain pixel that is wind speed. The brighter it is, the windier it is. So we will now take the next step and compress this data so that it actually looks really, really small, easy to read. Because this is what's going to happen. Even if we start with only 4 cities in the game, it's 659 megabytes of. So we need to compress this even. How do we sanitize it? That's going to happen after a short break. Let's put this simplex noise on the screen. But the stream won't be paused. I'll just be around stretching. So I'll come back soon. Simplex noise. After all, wasn't that simplex? But making progress. 1 pixel at a time, I suppose. Let's see. We do have the sanitized data. Now, in Godot, now here's sort of like a question. Anyone might actually ask this question, which is a meaningful discussion, maybe. Can't we just read this data during the game? Since we seem to know for each hour of 2010, the win data and whatever we do. That's data too. But this is only for 6 pieces of weather elements. So there will be many more. And it's still too big. In my opinion, that's really too big. So this file will only get bigger if we include some of these chunks. Okay. But it also is kind of a closed system, because once you get to that kind of like text data, randomization is a bit of different problem. When you have a texture file like this or image file like this, you could apply another simplex noise and multiply the values, so that actually creates randomization. Now let me give really undesirable values as well. If for this pixel, well, it won't, because I normalized it, right? So this is always going to be sort of between 0. Multiplication of those 2 images, as long as I stay within 0 and 1, there's going to be some kind of a threshold. It's like, well, randomize it 5% up and down. So the wind speed that you read for a certain hour will have a 5% variation. So it's easy to do that calculation over the whole image by, forgot the name. You multiply the channels in the shader. You just choose the blend mode to multiply. So that would be a really hard thing to do, to parse a whole JSON file here. Find each field and randomize some values. Plus it will be compressed. So now at this point in Godot, we could read this, start creating noise map, some noise. So let's open Godot, Farmer. So possibly a few weeks ago, I already started this whole process, creating noise map. Unfortunately, the original file structure was like this. This is still doing actually a whole bunch. However, we have moved on. Now have a much better way of processing data. So nevertheless, I'm going to repurpose this to creating this is going to load sanitized JSON file. let's start with that. Right now, we have something here, but not sure. I'm not sure if it's doing anything. So this is geography matters. On button pressed. Okay, pop up centered, which is this. Sorry, like an idiot, I think I had the microphone off for the last 10 minutes or so. So far, what I have done, filtered this file dialog box. Okay, so we can only import sanitized JSON files, and I'm able to read the number of records, so I will not process those records. And I was just discussing whether I need metadata for the output file or not, because this is Toronto code number that I know for sure by experience. We will either go with that in the game, that there has to be some kind of a lookup table that we know that record is mapped to Toronto, or we'll output the image file as toronto-2010.png. Because the game code still has to read that PNG file, right? And when it says, well, I need Toronto's file, is it going to look for text Toronto or the code number Toronto? Perhaps that is not a big deal at this point. Let's go about it this way. Let's create a variable here, and let's say let's call it image file name. Just an empty string at this point. The image file name is essentially kind of the path, but we want to replace .json with nothing. As much as you put the file size, also you put this, do this, do that, that. I have never saved it. Doing something wrong apparently. Path has to replace this. Again. And of course, I was only interested in this part. We got some junk too. For this specific current path, with these two, geography matters. Perhaps you should go under Noah. Current directory. What? Current file. Why can't you? Fucking mad with it. Still not be. So. Just be in here, man. Okay, thank you. That's still helpful. Okay, in here, we need to perhaps get this. How do we get this? We always know this is going to be a whole bunch of digits, dash, dot sanitized. So uh, let's take this into regular expression. Cool. Do something like this. Bunch of times dash this, a bunch of followed by sanitize. Actually, if you don't do that, it's unlikely that we'll have. So this is good. So maybe we'll do some kind of a capturing group. So you go back to your. We need regular expression. We'll do something like regexp new var regex new regex file this rule for string this. Okay, and on this we are going to do match, or path is a string, you do something. Valid escape sequence, because when you write this you still need this madness happening to you. What is wrong with you? Slash. Oh, with those always you need slash. Now you do path. Let's actually try our chances here. Search, which returns regex match. Subject is path. Okay. We don't really need offset and end. You just do path. Okay. This returns the match. Perhaps don't do this. Wow, you don't do this yet. Then we'll smarten it up. It's a regex match, which is essentially an array, as far as I know. Or, sorry, it's a dictionary. Yeah, it's about capturing groups and subject is the source string used to search. Start. An array of the match and its capturing. Okay, dot strings 0. That's really what we'll. In this case, we only have one match. This is the number of records. The last part is the file path, which is image file name. So that is going to be this. Oh, this. We don't really need to. This is going to be the file name, not the extension. We could pretend to write PNG file at this level, so we feel happy, right? Then dinner may come, be even happier. So image. New var image from get create from data with byte format data. That pool byte array is where. So let's create 100 by 100. Okay. I use mip maps. It's as if all this is mandatory. In fact, it is. Creates a new image of given size and format. See format constants. Fills the image with the given raw data. Use mip maps is true, then loads mip maps for this image from data. This is where we'll say false, because I don't go into some scary territory. I'm going to pretend that I have 3 by 3 image. This is going to be similar to noisemaker. Let's actually take this data. Okay. False. But compression. Image format now is RGB8. That's gonna data pool byte array. I'm hoping this will be good enough. The image has been created. This image has not been written into the system yet. By the way, I think there's a smarter way of doing it. Instead of just getting the file name, we should also extract the path too, because we will. For now, we are going to write the image here, but essentially it's going to be under work data. We'll figure that out. So right now, this is going to do its thing. Let's go back here, and then we need to have capturing. So this is one match. We need another match. Is anything you see this. So when you look here, group 1 will be to get that here. Something like some space. Put a slash here. That's it. So the first capturing group is going to capture this part. We may want to include this slash here too. So inside this folder, we are going to have this file name .png. So we need to do it this way. But when I do that, it's going to freak out. Let's just it that this star. I gotta do double here, double this. That's it. Image file name is great. Give me the whole strings again. Actually, keep that. Just give me the whole strings because I want to see the array itself. And we know the size already. Bye. We will do this. Let's save this. This is the data. Okay, that's just the data. We are interested in this part first. Fetch the plugin, come here, load the file. So in the first part, 0 is this is expected actually, because this is how it's done in JavaScript too. I think when you use capturing groups, um, 0 is always the whole string. Then you get to do 1 and 2 as the first capturing group. And so in other words, the file name is 2, and image path, image folder is regex results. Regex results string number 2 is that, and number 1 is the path folder. Get a feeling this is going to be okay. That. So, bye. So now we gotta save something. How do we save something? We do file new. Gotta do something var. This image file open. This is where I will have to write binary data. The path is this is where things will be interesting, because here's the folder. We are constructing a new path out of this. So this is going to be like plus file. What's up? 1 minute to dinner. Going to be strings. Pretend this is a string here. We can do plus file. On top of the folder, we are putting image file name. Does this take more than one? No, it doesn't. So we can do another plus file. We'll do PNG. File write. What are we writing in here? Image file store. This is something I have never done before. Store 8. Daily integer. This is 8. It's in the file. This is where I have to pause, and after dinner we'll get to see how we can write the binary image data into file soon. Let's write that image file. Not there yet. Gotta read the relevant section. File. There's also this compression mode that I'm thinking there's a way to open compressed files. How do you save a compressed file? So far, I have been using this to put a JSON file in the hard drive. Would this be our solution? Store what? Find out. So if this doesn't work, I'll just put a black image, hoping these values will turn into proper grayscale colors. When we do this, we'll close the file. Let's see if this is going to work. Here. Mode. File must be opened before you. The fact that it's trying to store 27 bytes is. Oh, okay. It got 9 bytes instead of 7. The fact that it's 9 bytes, it's. Okay, maybe this array. So when we do this, let's say 3 by 3, false format, we're going to be RGBA. Let's also look at this too. Empty image. This is good enough. Let's see if we are going to be able to write it. File must be opened before use. That's a separate error, but let's make sure the first error is gone. Yeah, file must be opened before use. What is the problem? File write. Read write. Must be opened before use. We do open it though. I don't think this file exists, that's why it's actually freaking. Okay, this is annoying. Opens the file for read operations. The file is created if it doesn't exist. That's I think I have a path problem. Just want to output this because I think there's something. There's this slash because When you do plus file, it's an extra slash, right? Yeah, when you do this, it puts another slash before path. So I'll just do a simple concatenation, providing my own slash here. Is essentially this. That path should be correct now. That's it. So that is the path. Good. Always something. Okay, not this one, this one. Toronto, this file, and did something. So let's file. Here's the PNG file. It's 16 bytes. Why is it 16 bytes? It's 3 by 3. We'll see the dimension. Can read file header because let's read some details. There are any. The fact that I'm marking the file extension PNG doesn't make it PNG. Putting the PNG headers. Is there something called, yeah, save PNG there? Saves the image as a PNG file to path. There is already something. So I was doing it for path. So let's do our image path. I feel like I'm going to go through a bunch of iterations here. Yeah, you'll smarten up soon. We won't do this. It's going to be, should work. You'll overwrite it. Okay. So here it is. 3 by 3, 81 bytes. Open it, it's a black image. You open it with fireworks. That's it, it's black. 1 pixel, 1 pixel, 1 pixel. 0, 1, 2, 3, 3 by 3. Perfect. Now this have to be color coded-ish. So hopefully this will work. Color coding, I mean this. It actually gives an error here because when we do create from data, it's expecting full byte array. Maybe what I'll do is full byte array. This is going to be from, or in this case, it's actually. This is hopefully will work. Hopefully. Something happened. Let's try again. Got 9 instead. Create from data. There's something missing here. So 9 bytes for the red channel. I have a feeling I have to provide 24 here. Let's go with this. I don't think this is still the right format. Here. Yeah, times 4. Give the data size. Missing something crucial here. Single 8-bit depth representing luminance. This is sort of what I want, really. Problem though, I'm passing GL texture format RG with 2 components. This is just red. This is red and green. 2 components. This is the 3 components. When creating an image, so far I've been doing this. RGB to linear color space conversion. This is what I'm hoping to do anyway. This is with the alpha channel. RF. Wow, okay. Of precision 16-bit. One bit of alpha color data being pre-multiplied. Okay. Sharp alpha transition. Perhaps no alpha transition. So far, am I using BPTC RGBA? RGBA, that's what I thought I was. Try to use DXT1 or DXT3, but not quite sure what I'm doing. DXT3. And this is still maybe not the best way of writing that file. There's still that missing bytes, but we are down to 16. That instead 9 bytes. So no matter what, I'm missing something here. Saves the image as a PNG file to path. Full byte array. But the image, let's go to the beginning of this. Okay. Data. Here's the format. Loom 8. So this is one of those formats, I believe. Where was I reading those enumerations here? Luminance 8. Height 0. This is, by the way, just the data. Texture is a whole different other game. Like the textures data is the image, so this image is basically data. This is more like renderable data. So that you create the texture from an image. Also created from data, so it's like data structure. I cannot say image texture create and if I'm creating from an image, I should already be creating the image anyway. Set data. This is set data. We are actually setting it. So we are back to this. Maybe I will seek line help. Look at the methods. Maybe I'm missing. There's compress, okay. Convert format, copy from. Crop, decompress. Okay, that's all fine. This fill is okay, but it's not really what we are. This is all the get stuff. Load PNG from buffer. And a buffer is essentially a pull byte. It's here to create. This is definitely what's going to happen soon. If we figure out even the saving, this is why I want to do the like basics, because I cannot even write a simple file with dummy data, right? That's the problem. So I wish they gave more help here. Problem is that this number is fluctuating right now, right? It's actually missing 7 bytes. I'm passing only 9 bytes. Expected data size of 16 bytes. So that happened because I'm passing this, which is a different game. Could you do something like, is there like a clear command for this? I think there was. Okay, expected data size of 8 bytes, you got 9. I think I'm doing something fundamentally wrong here. Tell you why. What if I did something like not this, txt1? What will happen? It's still 3 by 3, which is kind of like this. This is 9 bytes, but this is saying it's expecting 8 bytes. This is still going to 8 bytes, but all the way black. If this is okay, I'll actually do some pixel, and so then you don't really have that 8 bytes limitation, because you should be able to pass 9 bytes of information. Then this is sort of a different game than this one. Because this is going to work just fine, and here's the image, and in fact date created or date modified is, let's refresh the view. This the date modified, just drag this, actually change it. Date modified, yes, in fact it's changed in the last minute. So this is good news. If you look here, still, I think this has all the qualities that we want. So here goes nothing. Here's the array. Okay, we'll do something like, well, let's call it data. Data. I want to do for color in data. This is for one of the values. We do what image, save, set pixel. But we got to do this 3 by 3. So let's do a multiple array here. Okay, something like this is going to be the JSON data and later. We're just pretending that these are for row in data, or color in row, and might have to do size here. That's another array. So row and color is essentially the index. Color itself is can we create a grayscale color from here, from kind of multiplication? Like you do something like, well, it's either pure black or pure white, then you do hinting, modulate. Something like var the color, something like modulate, apply, blend mode. blend. Essentially, that's still the same color that I'm trying to create. Because this is essentially my row color 3 times. Redundant, but and then save it. You still have it open, but close. Run this. Open the file. Do it. Non-existent function size in base. Data row. Be an idiot. This image must be locked with lock before using set pixel. Okay. Image lock. Unlock. Locks the data for reading and writing. Sends an error to the console of the image. Okay. Before we write it, we unlock it. Otherwise, you get unlucky. Okay. There's nothing. Toronto, this cannot sit on compressed image. Sorry. So DXT is best format, I guess. We just go with B8, RG, B8. I'll get this done for sure. Done. Here's something. Try to open it. Ooh. Whitish, darkish. You know, you don't set this. Just do this. Whatever you think you are writing, or what you are doing. You are doing something funny. It's good. Yeah. Which means this color code here, this is wrong. Yeah. R float. Yeah, I have to normalize those values, which is going to come normalized from the JSON file. So this is good news. You can't just provide 120. When you do this, okay, it's always this, just this. Constructs the color from a 32-bit integer in. When you do this, it's similar to each byte represents. Yeah, this is what I need is something like this. So in essence, I'm dividing it by 2, providing values like 2 3 times. That's it. Was it? Do it. Open it. Still not quite there. Still not quite there. think I know why. The 8 here is the problem. Or not. It did probably override. Eight oh seven, 807. Open. I don't think the result is different. This is the problem, I think. Let me output this color or print out. I think I'm expecting to see something meaningful. This was okay, 127. Ooh, float. To be okay. Let's do this. It's converting into set. So when you do this, this is written okay, and here you're gonna have grayscale with this bingo. So look at this, and maybe even this. So first row, second item. First row, second item. Right? Why is this white? Shit, wait a minute. Because this is what I'm imagining happening. Okay, let's you're zero base, right? The pixel XY color. You know, I think I might have to do that the DST values must be integers. It's the color of the pixel. I see, that's a vector data. Interesting, but oh, I know what the problem is. I'm kind of resetting the row again and again. Right? So this is why I was hoping create from data would work. I'll investigate that too, but here so this is 0, then this is 0, 0, 0. I think that's not really working. I think we need to do this one here. Because this might be working with the it's not really taking into account zero-based index. There's only one way to find out instead of doing guesswork. I've actually gone with the guesswork too, but I'm gonna say it's out of bounds. So I was wrong. So it's actually zero based. Yeah, clearly zero based. What is wrong with you? Let's do it again. Nope. The data 0, which is that one size is color. 127, which is middle value. It's gray. So I'll try to simulate it here. Putting I'll make that 127 here, all the, which is pretty much this. In fact, that matches. And the next one is 64. I think this looks too white for it. If I come here and say you are 64, this is the 64, which is 1/4 in this area. 127, 192, 255, which is white. The fact that you should be here, but you're not, this looks too white to me. So here's the correct data. I'll copy it, paste it. This is actually what Godot is putting. Suddenly this goes to 255. That's the problem. So here it, oh, that explains, and this is going to be really dark. Then this is going to be exactly that. Okay. And then this is going to be black, which is 0, and then 34. So this is actually doing it in the kind of wrong order, so we have to swap this. This is going to be sort of column and row. Upwards. It's awkward no matter what. Perhaps I could have swapped it here. Slowly getting the hang of it, but I think I could have easily swapped that and be done with it. I made it less semantic. But I think I made it work. White, dark. Okay. Yeah. So here's what we can do. Create a bigger area. Put a dummy thing here. Okay. sample this. Look at the value. 127, which is 127. So this one will be 64. Or if we sample this one, this is going to say 80, and that's 80. So perfect. And let's look at the bottom row, 12, 34, 56. 12, 34, 6. Awesome. So that's done. We are able to save. It is not as pretty as this. Maybe I'll actually look into that. It's not a big deal. The reason being, I don't know at this point how many pixels I'm going to write in each row. There is the weather, the wind direction speed, that's 2 bytes of or bits of information. Plus some other things, right? So I don't know the length. So it's not always 3 by 3. And then we have many hours going in this direction. The entirety of the file is 1 year. So, however, regardless of being square matrix or not, if we could actually still consider this 9 bytes here as 1 hour's data, right? I will have many more of this coming in a loop. So it doesn't matter. Like, I should be able to write this as a 1 by 9 pixel file. So here we go. So let's do Godot, create from data. Is someone smarter than I am? Figure it out. This is the same documentation we see in Godot, unless we find tutorials here. This is not. So this is, yeah, okay. I don't think I need this alpha channel, to be honest. My mistake was something else. Anyway, I'm actually curious. Let me see. 115 bytes. If I do this, this should still work. Done. Yeah, 115 bytes down 7 bytes because it's actually not alpha channel. And I have a feeling we could cut this down even more. I will actually look into that right away. Try to get some water. Anyway, this looks like a fly. So this is uncompressed quality image. For 3x3, we are down to 108 bytes. Can we do better? Um, 8 bytes. Yeah. Just the red channel. There's no such thing as just the alpha channel, right? This might actually be an interesting case. I want to try this because this looked like luminosity or something. Just the alpha. Quite sure how that will work. Did something. So we are down to 99 bytes. Is this the same result though? I think it is. Probably should have copied the original good version. Halfway dark. It's good. So the L8 is did I even bother to create a function here that actually does something? By the way, why aren't we this one, right? Copy this, put it end of this, end of here, this. Kind of, I'm tired of this reading and writing. Imagine I'm not doing this, so I need to find a button to. That button is process line. So when process line is clicked, let's go this. Okay, we'll do something like do it. Okay, turn here. The function do it will do something. Doesn't exist naturally. Func do it. Okay, path. So you should now work. So stop complaining. Done. And here we are kind of doing the work of this. Func load sanitize data. Okay, this is going to do something which is going to do the job of this. I'm hard coding this. Later, this will change. This is still part of that healthy result set and whatever. Somewhere here, I'll actually trigger this at some point. This is the data, fucking data. That data is not important right now because I'm actually not doing anything, but I would actually have my own. Thing like this. Why are you complaining here? Malformed hex constant. Being just path. So this is I think it's complaining about this slash box. Since I'm hard coding this, it's really not important. Okay, that will all change anyway. We'll put a path here. So this is the path. That will all be different anyway. The fact that I'm not actually putting anything here, it's actually null. Or this, whatever. We'll replace this with a path later, which is going to return the data. Actually, this could stay like that. In do it. Here's our data. Yeah, I overcomplicated this. Okay, because I don't think I'm going to touch this at all. Here's the path. When you do load sanitize data path, this is still the path. Okay, you pass this here. So done with that. Here's the data. Now in button 2, we are actually triggering do it. So when this is garbage, because I will actually do this here. Delete this. Keep that as an origin reference. Let's put the files here. Something like compressed. Let's compressed. Enter. Here's your full path. Again, you gotta do the slashing. Do the slashy here. I have a feeling this can be converted into the plus file thingy properly. Okay, I will depend on that. So something like this plus file. And that's not a thing. Why is that? Yeah, it's malformed. Can't you just do this? And from consider this as proper string. Do this str. We are going to be a bitch about it. This. Maybe because there's space here. Plus file. And that's where we'll do the looping. Here's data. I will actually separate all this chunk into up. If there is any work done, this do it will be doing. So here's original data, image new. Okay, we are going to have some kind of a for loop here. That will be all the image formats. This is going to be interesting. because I need to put all this into an array. Okay, before I write this, nothing useful here except this. Image path. Yeah, that's what I was thinking. That path will be part of the operation here. So plus file is going to be the here, which put a slash here. That's also folder is here. Let's call this image folder. Compressed. However, we wouldn't mind this slash here, right? If we do it this way, this is plus folder, plus file. This is actually okay because it's gonna put the slash here. This file name thingy is going to be the important part. So let's do a print image file, image format this, and then let's just prematurely return it. You are complaining about this because there is no image file name. In fact, we'll investigate this at some point. So let's down here and let's comment out this whole thing. Let's do it. So now when I press the button, this button, it's just going to do it, which is going to print this, and we'll do something with this soon. Okay, it's 22. That 22 is essentially this. What am I doing? Format bptc rgba. Which is okay. Now I could technically do a counter from 1 to some top value here, but then I wouldn't know the enums. I don't have a list of formats, right? I think I'm going to do a basic regular expression to get some kind of array. Learn. We are interested in image format. Image. Things. All this part. Which is actually talking about it here, right? Bloom 8 or yeah. So take this. And the 37 is the size of the format enum. Okay. So this goes into here. Need to clear this. So technically all the bullet points, let's say here 25. It's actually here. It's not pasted here. This is a garbage thing, but what I'm interested in is everything that actually has format underscore and so format underscore something. until you see space. And you put this, and this is the list. So from L8 to RGB 8A1. That's exactly what's happening here. We could also put a comma, this, and this. Okay, now we have an array, or we could have an array. Do it, formats. Here is an array. A lot, you know, I don't need this. Undo. Just delete this. Okay. Still need to be able to do this. I think I'm going to take this 32 as well. That's going to be the value. That's going to be captured by this plus this. It's capturing everything. We need an object notation here, so something like because this is actually proper, right? There is no spacing here. So we do something like this. In Godot, something like this. So this is your dictionary. That's a smart way of doing it. Okay, that's your dictionary. So now what we can do here is for format in formats. The format itself is this. We could actually do it like this. Format. Clear. Refresh. Okay, and then the values will be because this is actually requiring integer. We have those. We don't need to format it this way. So now we are creating a new path. This is going to be the file name. So move this. It's commented out in it. Okay. We don't need to print it anymore. So image path is going to be image folder plus file format. Okay. We could technically take all this, put it up here, rent out. So we are creating a new image. Here's the image path. This is going to be the formats format value 1 something 0 to 30. I have not included the last one, right? Okay. So lock it, and then here's your data. Set it, unlock it, and write into that path. That path is compressed. This should work. We'll have 6 files here. Look at the comparison. Cannot convert image to PNG. I think it did some of them. In some, yeah, probably errored out in some. exactly at which point it source image is compressed. How many images do I have? 29. How many formats do I have? Let's copy this here. It'll find. $37. Checks out because the first one is 0. And yet when you got to 30th, you gave an error, RH. After that, there's a bit of a problem. What you said? $29 RH. RGTC RG is okay. Doesn't check out. RGTC RG. Oh boy. This should come before this. This should come before all this. So the index is not matching. That's awesome. So, okay. Delete all this garbage. In the file name, besides format, you gotta do something like this. Why we can't have nice things? The fuck? That's a number, okay. Interesting. That did not give any error, but did not do anything either. Have I clicked the button? I did this. Okay, I'm an idiot. I haven't pressed this button. Also, maybe I shouldn't actually print out every single time, which is okay, but it's from scratch. Do it. It's still the same 29. Okay. Perhaps what makes more sense to me is this. I have a feeling I have to pad between 1 and 9. No, I didn't have to. So 0 is okay. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24 is fine. 5, 6, 7, 8, 29th is the problem. 29th is the problem. Format etc. Ericsson texture compression format. This format cannot store an alpha channel. Who gives you an alpha channel? What is your problem, sir? don't even know if that's the problem. Let me just look this up. The original blah blah provides 6 times compression of. It doesn't support the compression of images of a compost, though there are workarounds for this. It takes 4 times 4 groups of pixel data, which in my case doesn't apply. I don't want to group my data like that. Compresses each into a single 64-bit word. It's smart. So I guess we are going to skip the etc 1 and 2. All the etc ones, which is all the etc ones. And to be honest, all the rest is actually etc here. So okay, who cares? etc, etc, etc. See? Ah, so 28, 0 is 29. We do have 29. It's good. Now we can start comparing. View details, file size. Can you show this in more? Okay, at least I'll go in order. 90 bytes. 9 bytes. This. So we have 90, 91, 82. Ooh. Another 82. The ext5 is 82. Of course, I gotta look at the quality of things too. ext5 is 82. I was optimistic about this too. BPTC RGBA, even though I'm not holding. RGBF. RGBFU. Thank you. Texture format that uses with unsigned floating point. With signed floating. Interesting part is this is the 82 parts with unsigned. So this are pretty much the same thing, except this one is using 1 byte more. There is no difference between these two except signed or unsigned. Funny thing is, I'm already using 1 byte to keep the sign. But that's my own concern. Unsigned normalized is what I like. Can be used for high fidelity compression. So BPTC float is for plotting point value images, commonly referred to 6. It's as if the ETC one is also referring to this, which I'm not really, but that's One for linear RGBA. So much information. I think we have a winner. So for 9 bytes, you have these two as winner. Now let's check if these two are sufficiently visually. Except it's crap. Problem. Because the data is not this. Garbage. So can we do better here? The large icons, of course, it's low, but this looks sort of dark, right? These are all kind of dark. Are they all dark? Let's see. Even this is good. This is the new image. This is the old image. I don't see any difference. This is good. Okay, let's look at the other 82 one. BPTC. BPTC RGBA 82. This is the one that is good enough to. Nope, that is crap. There's DXT5. It's not good either. So it says if only I could write another method that is comparing all this to this image. Clever way to write that is that take two images, subtract, and the subtraction should actually give you a perfectly transparent image. That means both images are the same. Or you do it one by one like this. Yeah, I don't want to write another layer. I think I'll do this manually. So this is the original image. Just push all this here. Okay. This has something good. This too. This is okay. This looks okay, because this is only using 2 channels, RG. Yeah. See, here's the thing. Since I'm holding, does it like I could use just one channel and compress this even more? You know, when they hold data in red, green, and blue channels, you could do things like this. And red, green, blue, whatever. When you change this, this is only changing the green channel. But if the green channel was empty in this, which isn't empty. Let's see, here it's empty because there is no blue channel. Let's see that again. Curves. Just the blue channel. I believe no matter what I do here, it's not going to have any. But if this was either red or blue, so red or green, there is going to be some difference. That's it. If I cut out 2 more channels, well, in this case, 1 more channel, just R8. Funny thing is, what is this RG8? It's 108, okay? This is essentially what it is, that I'm cutting out 2 more, 9 bytes. Which is, you know, 90 bytes, because just L8, right? Okay, let's cut this. It's a similar idea, just the red channel. So in essence, we could work out this too. But this is going to be so big. You could actually look at the brightness of red. That's your cut this. But let's do the testing here with the cubes that it's not going to be affected by green, either blue, but only red. That's it. The single channel. This is L8 with alpha channel, which we keep it. This is that original L8. This is garbage. This is another garbage. This is as if it's actually skipping some stuff, and I think this is where they talk about that such same deal here with all the PV. I want to read about this PV business. Power we are. It's lossy anyway. We don't want lossy. Yeah, fuck this. Okay. This is too size. Same idea. I think this is, yeah. That BPTC is fine, but perhaps it's not really helpful. This DXT is also okay, but overcompressed and misaligned and problematic. This looks okay. This is again red-green channels problem. This is the red one problem. This might be okay. Okay. This might also be okay. Problem with just RG. Okay. This is also red problem. This might be okay in my opinion, but because this is a special thing that it's losing one, instead of being what did they say with this one? Instead of 4 times 4 is 16. This is still 16, but it's actually taking from the alpha channel, giving it to RGB channels. That's why. This case is kind of killing it. And this is our original part. So here's what we can do comparison wise. Between this one and this one, I don't see much difference. This is one level zoomed in. Yeah, so between all this, I don't see a difference. This has difference. So it's as if until 5, all this is the same. Intentionally selecting it so that, except like all this is the same except this one is darker, and this is that 444 is a problem. Why? Okay, so we have the candidates. I'll just write it down. So we have 1, 10, 11, 14, 15, 16, and then 0, 1, 4. Let's go and read about them a bit. Starting with the 16. Special OpenGL texture format where 3 color components have 9 bits of precision, and all 3 share a single 5-bit exponent. Let's see. OpenGL texture. Okay. RGB AH. Okay. This is the half precision. So this is where we could actually cut down the byte size between 14, 15, 16. Or not. Maybe it didn't matter because it's grayscale. Don't know. Then from 14 we go to 11. 4 components, blah blah. Then there's 10, which is another OpenGL texture. Then we have 0, 1, 4, 5. This seems to be doing okay. There's 1 with 2 values, luminance and alpha. So this is basically just the alpha edit. This one is fine. 4 and 5 is RGB8, and this is just the alpha version of this one. So this is luminance value, this is color value. So I think this semantically or logically, this is what we want. But let's look at the file size. So this one is 90 bytes. 99. We don't want that. 4 and 5. So again, there's color information, just this is enough. This, again, some color information we don't. 11, we don't need it. 14, don't need it. 15, 15, nope, just this is the perfect combination for us. So it's luminance, it is. So we have to update our stream goals. We JSONified raw data. We're actually storing weather data compress in an image. We are, I would say 25%, 50% done. Is happy news. Okay, everything seems to be under control. So here is a quick metric for 9 bytes. We do have 90 bytes. For 9 bits of information, it's converting it to bits. What I'm going to do is, in this case, what am I? Wrong file. This should not be 3 by 3. This should be something like going to do something like this and inject some more data here. Going to do something like this. So for 12, see what happens. Clear. To be honest, this is all we need. In fact, let's do close all. Do it. This is all. So let's go here and here's the file. Let's put it in here. 3 by 4 or something. So let's look at the file size. It's 94 bytes. Interesting. So for this, it's 94 bytes. This should be another plus 9. No. Plus 12. I'm curious how this is actually going to. Can you actually do this and get a meaning result? It doesn't, see. It always. So. Yeah, we know this is all wrong anyway, despite the fact it's 82 bytes. Because when it's all wrong, why would you want to include? I don't have confidence that when you give a larger surface, it fixes itself. So what we actually said is this. Maybe we should actually smart. Which is 0 and 1 is okay. This is not good. 4 is okay. 5 is okay. 10 is okay, so delete until 10. 11 is okay, but 12 skip. 13 skip. 14, 15. 16 is okay, and all the rest is garbage. Refresh. I don't think this should give that problem. In fact, it didn't. So now, yeah, size is all the healthy ones. Among those, this is still the best one. This is for 12 parts here. Let's simulate another part. Let's do higher values. 2, 1, 2, 2, 33, 2, 4, 1. So for 3 by 5, 15 parts, what's going to happen? Out of bounds. Okay, that makes sense because I. 3 by 5, 94, 98. So for each 3 parts, it increases 4 bytes. Interesting. And it's always the smallest. I mean, big difference. Look at this. The other ones are adding many more bytes. Let's check the quality. So here's the 3x5, here's the 4x5. Let's actually take this and put next to each other. So let's do 6. This one to the right. So from here, it went up to this because this is higher numbers, so it's going to be more whitish. It's actually pure white. 250. This actually makes sense. The only thing we could do, this is just actually illusion. These two must be the same color. Are they in fact? Double check. It. It's matching. If you put this over here, side by side. The fact that there's lighter color down here makes you think this is slightly lighter, but see. This is 43. If you click this, it's 43. Just illusion. Perfect. So we have compressed lossless data. Now, what I'm going to do is I'm going to take this one, put it here. This one. Going to go by 4x4. Find something slightly different. So if I increase it by 1, it's going to be 4x4. It's a square file. Is it going to optimize it better? So from 15 to 16, there's a bit of difference. So if anything, it should be 99 or 100 bytes. Let's close all. 98 bytes. See? Despite the fact that it's slightly larger, it's actually occupying less space. It hasn't increased it. The same. This is that 43 one. Off. Because I changed it. The other one is 43. So. Yep. Okay. Perfect. So now that we know the smallest file size, instead of passing the data like this, which we might have to, but this is still kind of manually constructing it, right? We are setting the pixel values. I'm under the impression that instead of creating a blank file and setting the pixels, you'll be able to do this. So we have width, height, mipmaps false, format okay, but here's the data. Why can't we do this? In fact, can we actually do this? So this is when you lock and unlock. This is why I don't want to. want to do it like, in fact, this is not going to happen. Something like this, and among formats, we'll do format L8. This is the one. Full byte array, full byte array from array, which is data. Do you actually consider it like this? That when I initially gave it, it's picked out. Would you do this? In fact, where are you going to save this? The image path. This is the image formats, and screw this. Let's say this is going to be saved into image folder, which is compressed, and all this is requiring is some kind of a file name. We'll do this sort of manually. We'll do toolbar, okay, and don't do this anymore. This is all single thing. This, there's going to be a new toolbar thing here. Clear got instead 4 bytes. Original problem. Let me paste that thing here. Not that it's important, but so create from data is something that people were also looking up. The whole other thing. Expected data size of error. Oh boy. It's closed. So here's an interesting case. Dudes are loading existing files and creating the file from that content. Interestingly enough, expected data size of 16 bytes got instead 4 bytes. Here's a dumb question. Are you going to say I'm expecting data size of 20 bytes? Interesting. But instead you got 4. It's 4. Duplicate row. Instead you got 5 bytes. 5 rows. So gotta kind of flatten this, but I did that originally. Was there an easy way to flatten the array, or was I supposed to do that myself? Yeah. Take this. Do another regex. What we are interested in is we're interested in all the digits, multiple, just comma separate them. This is it. Okay, this is the full byte array. Var data. Data is already there. With image data, everything is fucking data. Full byte array. Full byte array from this array. That's data. Will you be able to do this? This is actually 20 bytes. This is 20 bytes. Will you do it? In fact, you did it. That makes me happy. 2 rows, same. So I have to create a linear I have to represent the data in a linear way. Huh. But that's kind of okay, because for each row, I could try to have a fixed number of cells or pixels, whether they are empty or not. Whether those pixels carry any weather measurement. As long as the length of each row or each object in JSON is the same, then I do imagine it's 100 we have 10,000 lines. It's always 10,000 times 100. That is my dimension. Because although it's easy to figure these two numbers out of this, when you have linear data structure like this, set of values, how do you break this down? Is this like 3 times whatever or 4 times something? You won't know. And suppose you could do it by, if I have like 4 rows, you can, what's the size, divide by 4, and then in that case I'll say I have number of rows like 8,000 whatever. It's going to be a billion number here divided by 8,000. Funny thing is, these values will not be short like this. It's going to be a lot of decimals coming like, which is already good because this is like the color value that well, in this case I was normalizing myself, but it's automatically converting. Oh, that's another thing. It's actually doing its own conversion. So it already thinks of this white, but instead I'm passing 1. What happens? Let's create another copy here. I'm not going to use this one. I'll say this is my like 0.5. This is 20. It's like I don't know, 133, something like this, and this is 180, sorry, 0.80. So this is 1.0, 0.0. 50 is again this. So how many is this making? 1 more, and this is going to be 2x4 files. So let's do 80%, 90%. Okay. 1, 2, 3, 4. 3 is 4. So we can easily arrange this by 2x4. I'm curious. This is going to create a file 2x4. Hopefully with proper colors. Expected data size got instead 8 bytes. This is a mismatch. So we did what here? 20, 5, 6, 7, 8, 9, 10, 15, 20. So it's 8. Yeah, I don't want to go back to this. Good. But this also means that I'm already passing it like this. Okay, it did. 2x4. I guess I didn't. Something. So it thinks all of it is 0. Yeah. Less than 1, right? Doing yeah, when you do create from data, here's the thing though. What if the other formats are respecting data like that? Maybe there is still some hope here. Here we go again with this. This time it's justified because I'm possibly not. I need to give more information there, which is missing. Can we at least do something like this, maybe? See, this did. Again, same idea. Okay, we have a bit of good news and bad news. I'm already normalizing my data in Node.js. Perhaps let's see how I'm normalizing it. See, this is normalizing it. Of course, it's between 0 and 1. Not necessarily mapping it between 0 and 255. Boundaries are this is going to sound awkward, but what if we did something like floor, math floor. This is not giving there is no clamp, right, in JavaScript. Could do round. There's a possibility that it'll go to it's not awkward. So let's do it this way. Don't return this just yet. Let this is between 0 and 1. Is there a name for this? Well, normalize really is what. Let's just call this normalized, okay? Under normal circumstances, this is what we would return. But this is not what I want to do. I want to multiply this by 255. So if this is 0, if it's absolute 0, which is this is 0, okay, over something, it is going to be 0. Wow, or with the minimum here. Yeah, because if something's minimum is 2, this is gonna come in as 2, which is gonna make this whole idea 0. So 0 times this is 0, and then we're already checking maximum. So this could be 1. So this is fine. Now, any other value, let's say 0.8. Okay, that's where the trouble is. Not that. So say 0.8 times 255. So this is actually mapping to 204. You try something like bunch of numbers, because this is the normalized value. 255. That's actually this, but this has to be converted to this has to be rounded. We'll say this is rounding. We'll never go over this. That's why I'm kind of confident. Say return math round. This is it. So now I will create this file again, except these values will not be reading kind of percentage values, because this is actually like 4%. The fact that this is 4% will read like a simpler example. This is 61% indirection, right? The 61% 00278 whatever, that is actually going to be rounded. This should read 156 in the end. Export the data. This is okay. We need to trigger this conversion, which is this. We'll refresh this and we'll see 156 here. In fact, I see 156. So that's the value that we are going to input here. Because when you do that, you get meaningful results. You do this way, you get dumb results. This could just be this, and you have 20 bits of information. This could be like this. It doesn't. So full kubar here, which is actually this is like this, or these two will stay the same. These two will come here. These two will come here. I'll see like in the fifth one, we are going to have white and black. I think that's really what I did here. Yeah, white and black. If I do this the other way around, say 10 by 2, let's say. Okay, fresh, close this and run this. Open the file again. Yep, fifth and sixth one is white and black. That's what I said. White and black. Okay, good. I guess it doesn't really matter which way I pass, this way or this way. I thought this was going to be required. That's why I was normalizing it. The other side of this is interesting. From this data, for example, this is the color, right, which is 127. Okay, 127. Perfect. Now this 127, if this is wind condition, going back here, how does it map to the minimums and maximums? In other words, same 127, which is sort of the 50%, right? Well, in the case of, let's say 157, right? Because that's it, 156. That 156 is somewhere in here, right? In fact, the because we are running things, we are losing a bit of that. Okay. Yeah, because it's like 61%, it's sort of 61. Okay. Worst case scenario, I will do double, like just 2 decimals precision, so that I could also have 2 decimals precision, because otherwise we'll lose data. But the point is, after reading the color code 156 from the graphic file, imagine it is. We should map that 156 to 61%. That 61% is going to be the 61% in this range, in its minimum and maximum, because not all the time you have minimum 0 or maximum whatever. Sometimes you have this. So in this case, 60% will be 61% of 2,300 possible values in between. That's really what it is. But this is a great step forward. And I think this is a good moment to stop today. I will fine-tune this process, but we have the basics of creating compressed files. And maybe next time we'll assume this is actually good data, and this is supposed to be weather, wind direction and speed. Maybe temperature stuff here is hidden. Maybe we'll display this data. So we'll run the timer in the game, so for each hour we are going to see these values change according out of this. So that will have to be time, most likely later tomorrow afternoon, but there's no guarantee. But that's it for tonight. Have a good one.